everyone, welcome back. I'm Domingos. I'm also called DMA and I appreciate when I'm called DMA. Today we have this exercise on logarithm equation to solve. A to the power 1 plus log of x to the base 3 plus a to the power 1 minus log of x to the base 3 equal a squared plus 1. A is a constant which is greater than 0 except 1. In other words, a is a positive number different than 1. So how do we solve this equation? Let's solve together and have fun. We have base 3 here and we have base 3 here. So we can let log of x to the base 3, the whole log, to be equal to a variable, let's say t. So when we we substitute back. We will have a to the power 1 plus t plus a to the power 1 minus t equal a squared plus 1. So applying power, they are adding the exponent. That means the base we're multiplying. When the bases are equal, we add the exponent plus a to the power 1 times a to the power minus t equal to a squared plus 1. Now what we do, we can say this is 1 over a to the power t equal to a squared plus 1. We can multiply both expressions by a to the power t. Here we will have a times a to the power 2t because the base will be the same and we will add the exponents. And here this a to the power t will cancel. We will have a equal all these expressions multiplying a to the power t. This is dot product. So you can send all this expression to the other side. We will have a times a to the power 2t minus a squared plus 1 times a to the power t plus this a equal to 0. It looks like a quadratic equation. So we can let this is a variable a. We know a is a constant. So we can let this to be like any other variable, like for example m. There's no problem. We can let a to the power t, because this is an unknown expression, because t is variable, a is a constant, so we can let to be equal to m. We let in the beginning and we let in again. So we're going to have a times m squared minus a squared plus 1 times m plus a equal to 0. This is a quadratic equation. M is the variable, a constant. So this is a constant. So we can apply the quadratic formula. We can say m is going to be equal to minus b. So this is my b. So this negative from the negative of the formula will become positive. Plus or minus square root of b squared minus 4a. A is a, and c is also a, over 2 times a, which is a. So this is the value of m. I didn't finish. So m is going to be a squared plus 1 plus or minus. We can expand this expression by applying the quadratic of square formula. So a squared plus 2, here is going to be a to the power 4 because it's square already. A squared plus 1 minus 4a squared over 2a. Okay, now we can carry on the other side. M is going to be a squared plus 1 plus or minus. We're going to have square root of a to the power 4 plus 2a squared minus 4a squared is going to be minus 2a squared plus 1 over 2a. M is going to be a squared plus 1 plus or minus. Here is the same as square root of a minus 1 squared over 2a. Now, can we eliminate these two and the index? we can say yes and no because we have to test first, because we don't know if this sum inside results in a negative number or in a positive number. But according to the condition, a is greater than 0 and different than 1. So that means a squared minus 1 will always be positive number. So we can cancel. If it wouldn't be positive number, then we will have to use absolute value to state that it has to be always positive. So we have a squared plus 1 plus or minus a squared minus 1 over 2a. So let's now solve finding m1. m1 is a squared plus 1 plus a squared minus 1 over 2a. I cancel the 1, so m1 will be 2a squared over 2a. I cancel them, 2 I cancel, it's a. So m1 is a. Now after finding m1 equal to a, now let's find m2, which is using the negative, remember, because we found m1 by using the positive. Now by using the negative one, we have a squared plus 1, this negative enters, a becomes negative and 1 becomes positive, over to a. We cancel a because they're symmetric, 1 plus 1 is 2, so we're going to have 2 over 2a. So m2 is going to be 1 over a, which is the same as a to the power minus 1. So we have m1 equal to a and m2. Now we substitute here to have the value of t. Now for m1 equal to a, that implies that we're going to say a to the power t equal to a. The bases are now equal, then we equal the exponents. So t is going to be equal to 1. I can say this is t1. Having the value of t, I substitute here to have the value of x, or I can still use m2. Let's use m2 now. For m2 equal to a to the power minus 1, we have a to the power t being equal to a to the power minus 1. The bases are equal. Now I equal the exponent. T will be equal to minus 1. So I have t1, which is 1, and t2, which is minus 1. So I can now verify by substituting here to find the value of x. So log of x to the base 3 equal to 1 first. That means x will be 3 to the power 1. That means x will be equal to 3. That's the first one. And then for x equal to minus 1. So log of x to the base 3 equal to minus 1. X will be 3 to the power minus 1. X will be 1 over 3. So that means the values of x are x equal to 3 and x equal to 1 over 3. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.